Joining is good. It should be learning. Because it should be disconnecting after 1 minute. Harish, Smith, am I audible? Vinaya?
Yes, sir, you're audible.
So in the last class, we have discussed about neural networks, and we also saw a video which was explaining us neural network to work on image processing and image processing or image kind of a data. Is the sound is audible to you?
Yes, sir, it is audible.
Okay. For those who are absent in last class, I'm just revising for 2 minutes. We just saw this. There was x values, there was y values. Alright. So here we have x values as the input layer and y values as okay. So feel here, I think you are here. Yes. So as you can see, the 7 is handwritten character. So this character is
Excuse
being
me.
taken photo. Yeah, Harish.
Sir, Supra is waiting for approvals.
In teachment.
Yes,
In
sir.
teachment. understand that 7 digital in terms of any number system that computer understands. Okay, so the task here is you need to let computer to understand this pattern. It has to tell that it looks like a 7. If you write a code with a handwritten character, it should tell at the output it is 4. Okay, for that you are going to train them. So for that, how do you give the input is the first question because of the first layer. So it says we have 784 values. So they are actually the number of pixels that it has divided because of those. Because rows and columns have been divided into one of the value. All right. Wherever there is a black color, here, so that's why it is blank. I mean, the highest white is 1, the darker is a 0.0. All right. So that's how this 3, whenever it is been written, so those 3 is being formed with the brighter pixels. Each pixel value is being given a number based on the brightness of the pixel. Right? Okay. Now, whenever I prove this pattern look like a 3, I have to assign each of the values like 0.0 each of the nodes to circles. All right. In those circles, we are going to write 0.0, 0.0. This is 1, 0.9, all of them. So each number is given to these circles at the beginning. All right. So these circles we are going to call them as nodes. Right. Okay. So got a W. So these weights has to be adjusted to form a optimal path to reach the output. All right. So let's see why. They divide the subtasks and they'll finish that thing. But in the process of finishing those tasks, everybody is going to share their work. How much I have done, how much they have done. All right. So that way, each layer is going to share their output to the next layer that how much they have done. So that next layer can start the work from there. All right. So that way, this is just the input, and next layer.
Node in the second layer. It can each node can submit output to the node in front of it. So if 783 nodes are there in the second line, this 784 can submit their output to 783 nodes.
Because of the equation that we have here. Yeah, here we have equation. Because of this equation, it has to submit the
each and every node in the next layer.
Yes, this is W0 is your 00, and this is 00. This is 00. I mean, this is your 0 W of 00. This is W of 009, and this is my A of 0. So this and this will be multiplied, and we will be getting the next node's value actually. And other nodes will also calculate the same way. By taking what you're calculating, you are calculating 0, 1 by taking what? By taking 0, 0, 1, 0, n 0. You are in the 0th layer. This
So what is it?
A is activation number or activation value. So here two numbers are there, 0 and 1. And what are those? Here we have You understand that it is A of 0 means it is the first node on in the list. But over this bracket 1? Bracket 1 says it's a layer. This is not next layer, this layer. So I am trying to calculate this value here by using this calculation. Alright? Okay. So that calculation will be done in this format. So we are going to multiply like this. Let this only be multiplied. Rows into columns. We multiply like that. So that's how this multiplication could be done, and it will be have you seen this earlier?
Yes.
Okay, two vectors have been taken, and their vector multiplication will be done. So what do we call the vector multiplication in mathematics? Dot product. So dot product, we need to call them. So we are doing the same here. So you are going to create this next layer with the help of previous layers inputs, and these weights, as we are talking about, they will be randomly assigned initially, and will be tried to go to the next layer with the help of the activation values, which are existing values. We know those values, and these weights will be adjusted based on the outcome that you are getting. If you are not getting the right outcome, then you have to adjust your weights, and then you have to try it again.
So we have to adjust manually or program will.
Program will do that. Adjustment will be done. Tuning, I mean, we have to write it and it will go automatically. Yeah, I just go back. This, this you can understand, right? A photo of mine written with a pixel divided, written with a. This is the activation. So whatever values we have A, that is my activation. small components are going to be recognized by the second layer. That's the work of the second layer. What is the work of sigmoid function? Threshold function, what it does?
Below the it will negate 0.5. Below 0.5 it will consider.
If I give any higher value or lower value, like -5, I give. So what does sigmoid do?
Plus 5.
-5, those which are below 0, sir, they will be pushed to the plus side of the curve. And those which are plus, they will be pushed to the negative side of the curve.
Like I'll get like 2.5 I'll get here. Then maxwell, right? Let's look at it. What it is asking? What value is asking?
It is asking for x.
Only x value is asking. Okay. If I'm giving a 2, for example, for make it easy. So what will be the value?
1/6, sir. 1/6.
1/6?
Yes, sir. 1/6 or 0.15. Sigma x equal to 0.15.
Okay. Listen again. Listen it again. And we'll solve the answer. can understand this? The numbers which are close to 1. Yes, ma'am. You told that there will be a threshold value, and whichever value crosses that will be going to have. Can I consider this as 0.5? And what are these green line?
Increasing value. 3, 4.
These 4, okay. So
When it is positive, increasing value.
Uh-huh.
Goes increasing up. You increase the length.
what's the last value? How much
Last
is
value is 1, sir.
Last is 1. We activate meaningfully when weighted sum is greater than 10. This is just an example. So you could take it as 0.5 as you're saying. The activation could be done even the probability or the value ranging from 0 to 1 could be more than 0.5. Then only I'll give you or allow you to go to the next layer. So we saw this yesterday in the program.
Sir, someone asking.
So we saw this function yesterday. Whenever we are saying activation function, that is calculated like this as A equal to sigmoid of NP of dot WA plus B. So this is the formula that we saw earlier. Alright, A and W are multiplying plus B they are added. So this equation is some arguments and you are doing the initialization in that. That's general practice. And then we have a def feed forward. Feed forward is the function name and as well as the mechanism of how the data is going to be going to the next layer. and here we are receiving the previous A in the current node or neuron. Alright. So if presently I am in the second layer, I am expecting my previous layer to give me that A. So that A is received at this place. Alright. This is A of 0 you consider. Then for B comma W in zip, biases and weights will be taken, and both of them will be used here in the dot product. That is LP dot, there is number dot, dot of W comma A plus. Here you are going to calculate the new A. This is your A1. Okay, the bracket wala A1. Right? So here this is your new A. This is your old A. You utilize this old A in the calculation. And after that calculation, you got a new A value, and that value you are going to same thing happen for all 784 pixels or 784 neurons. So new A will be added, and that will become one of the layer. All right. In computers, that kind of a diagram will not be available. So these kind of values are will be collected, and those values seem to be one layer. All right. Return the output of the network for an input vector. The same thing we have done in the function that is now other code. Okay, so for this one we are calculating, but we are receiving all